My name is Lungla. Today I will demonstrate that the magnetic field flow, the energy field, the magnetic field flow from the north to the south and from the south to the north. The current model out there, existing model, is only depicted or the magnetic field only flow from the north to south only, which is missing the other half. For the last 100 years or so, many of the physics concepts, concepts such as relativity, space, time, and quantum mechanics, is really hard to understand. And the question would be, is there a magical or a mysterious dimension that we cannot touch, test, or observe? Let us explore, and to find out that the answer is no. The symmetry has always been there with us in this world. And I will set up the demonstration to show the flow both directions. Before we get into highly detailed, this is the current model of the a bar of magnet, which is supposed to be equivalent to something like a magnet generated by a solenoid, which is you take the current and the flow and the right hand rule, the magnetic field wrap around. And then if you make a coil and like a solenoid, then you collimate or align all this looping field, and you create this. But this is actually, because you can see it's looping, while the bar of magnet, it will be, the corrected one should be like this one, because it have the other direction. It not only flow from the north to the south, but also from the south to the north. The flow of both directions is not new. This is in 1644, when Rene Descartes draw this picture of the Earth and the magnetic field, and you can see the helical field. They flow both directions, from one pole to the other, and the other flow this pole. This is called a vector field. And the vector field, basically, if two field flow, and if they meet more than 180 degrees this side, they will deflect this way. And if they bend this way, they deflect this way. And so, and the experiment I want to show is, if you have two magnets at 70 degrees separated in a V, then you have North Pole here, and South Pole here. So in the current model, we'll predict that the flow will flow from the north to the south, and the north from the south here. And when the vector field, the flow, they go from the north to the south here, there's going to be a collision right there, and you can see the deflection here. And we have something look like a diamond shape, like diamond shape in the middle. On the other setup, going to be, if you have the two south poles away and to the north pole opposing each other, so they're going to deflect this way, but the half will flow this way. There shouldn't be hardly anything here. If you drop iron filament, they're going to be a lot different than this. Because if the current model say there is no flow from the south to the north, so you don't have all the field here go from here to here, then it's end. it doesn't go this way. So it's not possible to have a vector field flow from here to here or here to here. There's some of the three-dimensional field flow, and they might have some scatter here, but there would not be anything resembling this. It mainly would be random direction of the iron filing. So what you're going to see right here, you got the close in, is the setup I described, and I will try to get as close as I can here. So what you have is you have two north poles, that's in the V 70 degree, and the south poles are opposed in here, but it doesn't matter because it flow in this way in the picture. And this is the north pole opposing each other, and so there shouldn't be iron filing here. Would be random if I drop filing here, mainly random here. So what I'm going to do is I'm going to put this Glock in here, and I will put a piece of paper and then spring iron filing, and you will see the shape. And first of all, we'll do pole check, and this is the little magnet here. Red is north, and blue is south. So, and to check, make sure this is north, the blue going to meet the north, and this here was over to the south here. So the red going to go together with the south pole here, and the north here, and the north going to go with the south pole here. So we have the pole check. That's what I do, a pole check. And going to put the iron filing here, over, here, over. So pretty much we want to cut a plane. We don't want to just pretend that it's a perfect plane so you can capture the field. And the line, it's just a convenient so that you can see this drawing of all the field line. It's a convenience for your convenient visualization, but the field is, it's quite, it's there, but it doesn't have an arrow for you, so it's really hard to see. So here you go. So now I'm going to put iron filing. And you can see here the magnet going to show up right there. That's the magnet. What interests most is what in the area between the two magnets here, that are vector field. And the other one is pretty straightforward. Okay, a little bit more. I think it's fairly obvious here. You can see. I will zoom in. There is a diamond shape here. You see the deflection this way. Let me put it there. Deflection this way, and the reflection up far above is a little higher because it's harder to see, but it's there. And I'm going to do for that is the up pole, the two north pole up, and now this is the two south pole up. And I shouldn't, now I'm going to establish where the magnet located. There you go, there's the magnet location. This one I put extra, we'll put some extra here so we can see the similarity. amount. Okay, put a little bit of this in here, a little side, a little side, a little side here, a little side here, so you know they'll feel there. Alright, so I'm going to zoom in so you can see the field. Okay, so it's supposed to look like this on the left. On the right, it's supposed to be random filing, no direction. So now I'm going to zoom in. I'm going to move the okay, we'll move a little bit here. That is the north and north. Look like it's too close. There you go. You can see the deflection and the vector field flow. A little diamond here. Now you swing over, and this also have the deflection and both way, and a diamond here. Let me zoom in. Well, the camera they're not doing a good zooming here. Okay, so let me zoom out and go. So from this picture, you can interpret right away. I mean, of course, from this, these experiments you can do yourself, and from observation, you should be able to see that you will get the same result. And clearly, the field flow from this south pole to the north pole as well. And this one, the north pole, go to the south pole. 42, and I say I got that angle. So and this would be, if I do a 6, I'm not going to conduct this because it's a harder experiment, but if you have 6 and you have 6 opposing north pole here, that means most of the field will be blocked from each other. And the south pole shouldn't have much, if only the flow from the north to south. There's not much of the activity here, nor you're going to see this kind of interference pattern or deflection pattern. So this is what I set up. And now I will take this 2 here, and I will see the vector field flow of the 6. And you're going to see that I zoom in here, you can see the deflection, and the diamond here, and this is 2 south poles. So another data point to indicate that the magnetic field flow also from the south to north. Because again, I mean, in this case, let me repeat it because it's important here. If we flow only from one direction, then everything from the north will terminate to the south look like this, because there should not be anything go from this angle. Same thing here. So, but obviously, clearly, there's the flow pattern. So I thought that, okay, if I set up something like this, it's a little more complex, but the experiment here, I can have first describe it. If the flow here north here, the flow to the south, you can see the faint arrow go this way, and it's twisting around, but you see this arrow go this way. But what I want to set up is, as it go, and when they wrap around the other field flow, and the coiling or the twisting here wrap around, it's going to be more intense over here, so that overall the the path. It's going to travel as the path of the wave. They're going to travel slower than if it was a straight curve. And same thing if I do the opposite flow. This way, what I can demonstrate is that when this happens, and then you're going to see the flow event for from this end, because there are a lot more of the field here, and they flowed out this way, and the same thing flowed out this way. In order to do this, you inject material into the field, and as material flow, I mean, this not material, I mean atoms or elements in here, and this become a current. The magnetic field become a current, so become an electric. Think of electrical current, and in itself, and then if you want it's on this mode, the atom will whether lose electron or and then they begin to move around and have a lot of collision, and so they become a plasma discharge. And so this way you can see plasma discharge go from both directions, this way and this way. So that way you can actually clearly see. And in order to conduct this experiment would be complicated. However, I will point to the video of something nature already provide. So that is the two colors. You can see I depict the red is the north pole flow, blue is the south pole, from the south to the north pole, and they will make this happen like this. But I converted it to become magnetic field with electromagnetic field through rope. That's what I try to say. And so that's the setup. And now I'm going to show the video of, zoom in. Okay, now wire is still clear. Okay, now it's clear. And we can see this video, it's called NASA Fiery Looping Rain on the Sun. It's on YouTube. I will put this in the link of the video, and you can see. Okay, zoom in a little bit while it's still clear. Okay, this little dot over here, this is Earth size, so that you can see what the scale is. So this loop is really large magnetic rope flux, and there are a lot of names to it because the material, when it flows from one end, the material will get pick up and transport upward, and the flow the other way also pick up and transport upward. And that's what I try to describe here. Because again, if it flows like a river only one direction, then you only see it flow only this way or this way. But now I'm going to go over here. All right, let me move. Okay, let me do that. Okay, let's watch this video. It's exactly what I described there. Plasma discharge near the surface here, and things seem to flow from the top down. But actually, because of the transport up, the material is then still dark. They're not as bright. But by the time they get wrinkled up like this, then it's brightened. And so let's just go even at some of the more fantastic it flow here. You can see it flow like a fountain going that way. So the magnetic field flow, which is driving pick up the atom and all the material upward, both directions. So from that video, clearly you will see that the magnetic field flow from one pole to the other. It's not just one direction that we depicted by using the current model. And what happened, what the implication is because well, first of all, the reason behind for the current model is pretty much, it's about, and we got it right here, it's about really about 1825, the year 1825. Ampere proved that the magnetic field created from the electric current is equivalent to the magnetic field. And there is an extrapolation, and apply that also will work for, say, a permanent magnet instead of electromagnet. And so that because to create a magnet, there are mainly two modes. One is you're doing a looping type, an electromagnet, and the other one is twisting type, either by the crystal structure or by the motion, the spin. So the electromagnetic got extrapolated incorrectly into the other type. That's why we end up with a model that missing the flow from the south to the north. And so the implication is, in order to compensate for a missing flow, Einstein, for example, had to come up with special relativity to explain when you have a moving charge and then a current, and that moving charge only got repelled away. And so, because again, there is the missing pole that play here. And for quantum mechanics, always been looking for the symmetry within another dimension, whether in the virtual particle or in the antimatter world or all these worlds to compensate. Statistical wise, it worked great. But it's these extra dimension. Okay, go back to space-time. In order to explain the repel mode, and they have to invoke the space contraction. And so, and in essence, it will lead to quantum mechanics also, which is also in sort of that dimension that is affecting this dimension. And so, all of this because of the mathematics. Was try to simplify back in the Ampere day. And it's great when you only have one direction instead of two direction flow. And so we are not missing a field. Missing a dimension or the other symmetry. Everything always been with us. And in order to explain in terms of physics, chemistry, or life, the missing half has always been here. So, thanks for watching.